This is question 33 in chapter 1. So the information we're given is that the professor travels north 3.25 kilometers, 2.20 kilometers west, and 1.50 kilometers south. So if we put that on a graph, it would look like this. This would be west, this would be east, north, and south. So we will call this vector A, this one is vector B, and vector C. So going along here, he went up, vector A, and then he went west, vector B, and then south, vector C. Now the way I solve this is if you continue this onward, makes a straight line, and then you can make a triangle down here, making this a right triangle. Now you just need to find the angle here, which we'll call theta, and this hypotenuse, which is alpha. So you know the distance from here to here is a 3.25, and then the distance from the 3.25 to the tip of this is just 3.25 minus the 1.50. So we can find the difference between the two. So 3.25 kilometers minus the 1.50 kilometers right there would give us this distance right here, which is 1.75 kilometers. So now that we know this side, we can just solve using the opposite over adjacent, and we also know this length because of this length up here, because they're equal. So this would be the 2.20 kilometers. So to find theta, it's just going to be opposite over hypotenuse. And that will be, we're going to use inverse tangent of this opposite over hypotenuse, which is 1.75 over 2.20 kilometers, which equals 38.5 degrees facing northwest. So that's one of the answers that it's asking for. Now we have to find the hypotenuse, which is alpha, and we're just going to use the distance formula, which would be alpha equals, this would be x squared plus y squared, or a squared plus b squared equals c squared. So you just change the formula to get what you need. So it's going to be alpha equals the square root of 2.20 kilometers squared plus 1.75 kilometers squared. And if you plug that into your calculator, you get alpha equals 2.81 kilometers. And that is the other answer for number 33.